Okay, in this video I'm going to show you solutions to these IPv4 subnetting problems. The first one asks you to fill in this table, and I have it filled in here from my Excel sheet. And what we're doing is we're looking at taking a Class C network and breaking it up using fixed length subnet masks. Okay, so that means every subnet is going to be the same size. And when we start with a Class C network, that means the N is equal to 24. 24 bits are used for the network ID. And we have 8 more bits in our IP address, which can be divided between host bits and subnet bits. In the simplest case, we allocate all of those 8 bits to the hosts and none of them to the subnets, in which case we have one subnet, and the number of subnets is 2 raised to the s power. So the number of subnets is 2 to the s power. The number of IP addresses is 2 to the h, number of IP addresses in a subnet, and the number of hosts is 2 to the h minus 2. And you can see we've got 2 to the h minus 2 in the hosts, number of hosts column, and we've got 2 to the s in the subnets column. And so there's a trade-off. As you go from a /24 to a /25, in a /25 we get 1 bit for the subnet, and so we have 2 subnets, either a 0 or a 1 in that 1 bit, and we have 126 hosts per subnet. Now the last column here, number of hosts total, starts out at a maximum of 254, which is 2 to the 8th minus 2, or 256 minus 2 being 254. And then the idea is that as you break it up into more and more subnets, the number of subnets goes up as the number of host bits goes up, but then you're wasting more and more IP addresses on subnet IDs and broadcast IP addresses. And so the total number of hosts available goes all the way down to 128, which is half of the original value, more or less, meaning that in a subnet of size 4, only 2 of them are usable, the other 2 are wasted, and so half of them are wasted. Okay, that's why it goes down to 128 there. Okay, so this table is easy to make, and this one is something that you can almost get going in your head. What you're doing is you're taking 32, for example, on a /27, you're taking 32 minus 27 is 5. That leaves 3 for subnets, gives you 8 subnets, and also gives you 2 to the 5th, or 32 IPs per subnet, 30 addresses per subnet. Okay, and so let's go on to problem 2 here. Problem 2 essentially uses this table here. And for example, it says consider the scenarios given, and the question is, will those scenarios be accommodated by a Class C network with fixed length subnet masks? So all you have to do is look at the table above here to answer these questions. So if we need 2 subnets with 126 hosts each, we can do it. 2 and 126 mean a /25. And so I said 2 subnets, 126 each. Yes, it works with a /25. 3 with 62 each. Yeah, we've got 4 with 62 each when we do a /26. So that's another yes with a /26. Part C says 3 subnets with 24, 48, and 64. Well, because we're using fixed length subnet mask, we have to look at the largest of these. We're going to look at the 64. And the 64 on the number of hosts per subnet is going to push us up to a /25. Because 64 is greater than 62, we can't use /26. So we're forced to go to a /25, but then there are only 2 subnets, and here I'm asking for 3 of them of that size. So part C is a no. So hopefully you get the idea. 6 subnets, each needing 30. Well, with a /27, we have 8 subnets, with 30. So it's a yes with a /27. Part E, 6 subnets, 5, 10, 15, 20, 25, 30. Let's do 6 subnets with 30 each. Yeah, that fits. 8. We have 8 with 30. So E is another yes, same answer, /27. F, we want 7 subnets, 5, 10, 15, 20, up to 35. 35, you just look at the number of hosts per subnet. 35 pushes us up to a /26, but there are only 4 of them there, and we needed 7, so F is a no. 35 requires a /26, but only 4 of them are available, and 7 of them are needed. Part G, 14 with 14. Yep, it works because a /28 gives us 16 subnets with 14 each. Yes, /28. Finally, 15 subnets, part H, 15 with 15. No, it won't work. If we want 15 per subnet, we have to jump down to the /27, which is only 8 subnets. Okay, so 15 requires a /28, but only 14 of them are available in each subnet. Finally, part I, 33 subnets, each needing 4 IP addresses. Well, if you need 4 IP addresses, you have to go to a /29, and we've only got 32 of them, so that's another no. We needed a /29, but only 32 available. Okay, so hopefully you can look at questions like this and just look at this table and answer them very quickly and give us some sort of a justification saying, like I've given over here. And I'll stop there on this video and move on to problem 3 in the next video.